Hello friends, welcome back. This is second part of our discussion on steam trap. In first part we discussed certain terms related to steam trap. I have given link in the description of the first part in case you want to refer. Now let us proceed our discussion on a steam trap in this part. Let us see what happens when a steam line is charged. At a startup, steam line is filled with air and some non-condensable gases. This air and gases need to be vented. Steam can enter the line only as fast as air can be vented. Mixing of steam and air reduces the heat transfer rate because steam and air mixture has less thermal conductivity compared to pure steam. This is because air acts as insulator. Other than air, non-condensable gases is present in the line also need to be vented to atmosphere because the non-condensable gases in the condensate form acid which corrode the system. On a startup, steam comes in contact with cold pipe and it will start to condense. The condensation rate will be maximum at this startup because the temperature difference between pipe and steam is maximum at this stage. The condensation rate at this stage is called startup load. Once the steam pipe network is warmed up, the temperature difference between steam and pipe is minimum, but still condensation occurs due to heat loss to surrounding atmosphere. The condensation rate at this stage is called running load. The formed condensate falls on the bottom of pipe and is accelerated by steam in the direction of flow assisted by gravity due to the gradient provided in the steam line. Presence of condensate decreases the heat transfer rate due to reduced thermal conductivity. Reduced heat transfer rate has impact on increased warm-up time of the plant and hence it reduces the performance of the plant. This is why removal of condensate, venting of air and non-condensable gases is essential part of the plant performance. Condensate is drained from the strategic point in the steam pipe network by means of steam trap. Steam trap acts as an instrument for all of the above requirement. Now let us see what will happen if condensate, air and non-condensable gases remain in the steam line. First of all, water hammer will start due to condensate as the pipeline will be having two-phase flow. So vibration, physical damage, rupture of pipe along with corrosion will start. We will be having reduced heat transfer rate due to condensate mixed in steam. Also, there will be reduced heat transfer due to air mixed in steam as air is acting as insulator. Non-condensable gases will corrode the system and will also reduce heat transfer rate. Overall, we will have low performance of steam system due to reduced heat transfer rate. What is steam trap? A steam trap is a device used to discharge condensate, air and non-condensable gases with negligible consumption or loss of live steam. We can also say it is a kind of automatic valve which will open and close to discharge condensate, air and non-condensable gases. Functions of steam trap. To discharge condensate as soon as it is formed. This is the main function of a steam trap. Then it shall have capacity to discharge air and non-condensable gases. It should have negligible steam consumption, that is energy efficient. And it should be reliable in terms of usage, that is optimum performance with minimum human attention. Types of steam traps. Basically, as per ISO international standard, all these steam traps fall under three categories. Mechanical steam trap, it operates based on change in fluid density. Thermostatic steam traps, it operates based on change in fluid temperature. And thermodynamic steam trap, which operates by change in fluid dynamics. Further, we have two types in mechanical steam trap: ball float and inverted bucket type. In thermostatic steam trap, we have three types: liquid expansion steam trap, balanced pressure steam trap, and bimettalic steam trap. Ball float mechanical steam trap. In the ball float type, there is a ball float which is attached to a valve. This ball float rises up and opens the valve once the condensate is filled up to certain level. There is a thermostatic element which releases the air and non-condensable gases at startup. In the earlier design, this thermostatic vent was missing, so an additional valve was used which was operated manually to release air and non-condensable gases at startup. Now let us see the operation of ball float steam trap. At startup, thermostatic vent valve is open. Air and non-condensable gases are quickly discharged through the thermostatic vent valve. Cold condensate starts filling the trap body, and as soon as it fills up to certain level, the float rises and opens the valve. The cold condensate starts getting discharged through the open valve and also from the open vent if the entire trap body is filled with cold condensate. As soon as condensate reaches the saturation temperature, that is hot condensate comes in, the thermostatic vent valve is closed and now the condensate is discharging only through the main valve. The opening degree of the valve is regulated by condensate level in the trap body. Once condensate level starts falling and valve is closed and no condensate gets discharged, the upper part is filled with live steam. The remaining condensate forms a water seal in the trap body which prevents the loss of live steam. The thermostatic vent valve remains closed until air and non-condensable gases accumulate during the normal running operations and causes it to open by reducing the temperature of air steam mixture, because as soon as the air and the non-condensable gases mix in the steam, it reduces the temperature of the air steam mixture, and then thermostatic vent valve opens and discharges the air and the non-condensable gases. When fresh condensate again enters the trap body, float rises and starts releasing the condensate through the valve and cycle gets repeated. We see that due to difference in the density of the condensate and steam, the float is operating, that is opening and closing the valve. When high density condensate fills the trap body, above certain level the trap opens, and when low density steam fills the body and the condensate level falls below certain level, it closes. This is in brief how ball float steam trap works. Inverted bucket steam trap. In this, there is a bucket which is inverted. This bucket is attached to a valve through a lever. Movement of bucket up and down closes and opens the valve. There is a small hole in the top of bucket to allow air and non-condensable gases to pass through. Now let us see the working principle of inverted bucket steam trap. The inverted bucket within the trap body will rest at the bottom, keeping the valve open. The condensate fills the trap body and discharges through the open valve. The small amount of air passed through the bleed hole and also gets discharged. As soon as the steam comes through the inlet, it starts filling the bucket. The bucket rises up due to the buoyancy effect and closes the valve, and thus live steam is trapped. The trap remains closed until the steam in the bucket has condensed or bubbled through the bleed hole to the top of the trap body. The bucket will then come down and opens the valve to discharge the accumulated condensate, and the cycle gets repeated. The air entering at startup will also give buoyancy to the bucket and closes the valve, but the bleed hole then discharges the air into the top of the trap body, and thus bucket comes down and opens the valve. Air is then finally discharged through the main valve. So this is in brief how this inverted bucket steam trap works. Thermostatic steam trap. As we saw, thermostatic steam trap works on the principle of change in temperature. Figure shows a liquid expansion steam trap. There is an oil-filled element inside the trap body which expands when heated and closes. The valve attached to it. An adjustment nut with a spring is on the other side of the trap. This adjustment allows the trap to set the discharge temperature of condensate. Usually this is between 60 degrees centigrade to 100 degrees centigrade. So the trap will discharge at predefined temperature. At startup, the valve is open and discharges air and cold condensate easily. When condensate temperature reaches to the set temperature, liquid filled element gets heated and expands and valve is closed. Once the condensate cools below the set temperature, it again starts discharging the condensate. The condensate outlet is always upward so that oil filled element is continuously immersed in the condensate so that it can operate based on the temperature of the condensate. As the trap discharges to the condensate at a set temperature like 100 degrees centigrade or below, so it is not a good solution where immediate discharge of condensate is required after formation. So this is in brief how liquid expansion steam trap works. Balanced pressure steam trap. In this we have a thermostatic capsule which is filled with a particular liquid which gets vaporized after heating and moves the valve attached to it, and this is how it closes and opens the valve. In this figure we have inlet from the side and outlet from the bottom, and thermostatic capsule is fitted in the top part of the trap body. This thermostatic capsule can also be replaced once damaged. Now let us see the operation of balanced pressure steam trap. At startup, the thermostatic capsule is relaxed and valve is wide open. Air and cold condensate gets easily discharged. As the temperature increases inside the trap body, capsule starts expanding. Just before the condensate reaches the saturation temperature, that is when hot condensate enters the trap body, capsule expands completely and closes the valve. So there is zero loss of steam in this case. Due to heat loss to the surrounding by trap body, the temperature decreases again and capsule element starts contracting, opening the valve and releasing the condensate until it again closes due to hot condensate. So this is how balance pressure steam trap operates. Bimetallic steam trap. In this, bimetallic strip is attached to a valve. At startup, the bimetallic strip is cold and flat, and valve is wide open, discharging air and cold condensate. As the temperature increases in the trap body due to condensate, bimetallic strip starts bending and valve starts moving towards valve seat. Just before steam reaches, valve closes and traps the steam. The operation of a steam trap takes place at a certain fixed temperature, that is predefined temperature when it will be closed, at what temperature it will be closed. Due to heat loss to surrounding by trap body, temperature decreases inside the trap body and the valves reopens and starts discharging condensate, and thus cycle gets repeated. Thermodynamic steam trap. It works on the dynamics of water and flash steam, that is Bernoulli's principle. After inlet, we have a strainer to filter foreign particle. There is a flash chamber to contain flash steam. The only moving part in this is disk, which moves up and down to open and close the trap based on the pressure. At startup, the incoming cold condensate and air pushes the disk up and gets discharged easily. When hot condensate flow through the trap is still open and discharges condensate. But high velocity of flowing hot condensate creates a low pressure under the disk. Due to low pressure, flashing of steam happens, which fills in the flash chamber. Now make note of two phenomena that is happening together. First is the pressure application area under the disk is less compared to above disk. That means above the disk the pressure application area, surface area, is more. So flash steam, which is above the disk, applies more force compared to the force applied by flash steam under the disk. And second phenomena is the pressure under the disk is low due to high velocity of condensate flowing outside as per Bernoulli's theorem. So in total, we have more force applied from the top of the disk compared to the force applied from under the disk. Due to this, disk comes down to its seat and closes. The flash steam is trapped above the disk and cannot flow outside. The trap remains closed for a certain period and hot condensate keeps accumulating. After a certain period, the flash steam above the disk condenses due to heat loss and the valve opens as the disk moves up due to high pressure applied by the condensate from the bottom, and the cycle repeats. So this was in brief regarding the understanding of steam trap and its operation. Thanks for watching. If you like our video, please like, share and comment. Your like, share and comment is a motivation for us to bring a new video for you. Thank you very much.